This is an introduction to Chapter 6, Part 2. And basically, we're going to look at sequences not of numbers like we did in Chapter 2, but of functions. And very much related, we can look at series of functions. And we can ask questions, as we talked about in last podcast, or last screencast. But I just want to look at this particular sequence right now and give you kind of a graphical idea of what happens. 1 over nx. There's x, there's 1/2 x, there's 1/3 x. So we're going to look at a graphical representation of this by finding the right place. I'm good at this, aren't I? There we go. Nope. I'm really good at this, I mean. Right, so there, see, now it's going to run through 1x, which you just saw. Now it's going to go through 1 over 50x is what it's doing. So it just jumped to 1 when it goes up, and now it's going to 1 over 50. So you can see that this function, that this sequence of functions is going to converge to 0. Because when you go to x down to like 1 over 20x, 1 over 30x, 1 over 40x, 1 over 50x, it's going to converge to 0. So what we can say is that this function here converges to 0, where the graph of 0 is not 0 the number, but rather it's 0 the x-axis. So finally, for the introduction, let me just tell you mainly why this might be useful. Our goal is we want to understand how to write functions kind of nicely. E to the x is one of our favorite functions from calculus. The problem is that e is a pain to work with because it's all irrational. But you've probably seen before that this is equal to the sum of n equals infinity, 0 to infinity of x to the n over n factorial. So this is equal to, it's equal to 1 plus, if you plug in 1 you get x, plus plug in 2 you get x squared over 2 plus x cubed over 6, because 3 factorial is 6, plus da 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 da. So our goal is we're going to want to understand these series, which are called power series because the x have powers, and they're useful for describing other functions that we want to know. For instance, it's much easier to work with this if you want to approximate e to the x. If you want to figure out like e to the 17, it'd be much easier, instead of figuring out what e to the 17 is, to plug in 17 into this polynomial, 1 plus x squared over 2 plus x cubed over 6. You can even stop there. That'd be an approximation. So let me show you what this looks like. We're going to toggle back and forth just a little bit. Here we go. Okay. Except I need to bring this down a bit. So here I have the function e to the x. Now what I'm going to do, I didn't really want to do that. What I'm going to do is I'm just going to quickly put this in here while you watch me. Equals 0, k equals n. Here's e to the x. What I'm going to do is I'm going to click next term, and what's going to happen is in red, it's going to pop up just, if you just add 1, what's the function 1? And you'll see it's not really working. There we go. This is actually 1 plus x. It did 2 of them. So here's e to the x. Here's 1 plus x, and you get a line. Not too impressive. But the next term is going to be, if you do 1 plus x squared, you get this. Oh, it's getting closer. 1 plus x squared plus x cubed over 6, you're going to get this. Oh, it's getting closer, at least on the left. Okay, let's add another term. Let's add another term. Another term. Another. And you can see we're just getting closer and closer to that green function. And we have an infinite number of these terms, so we're going to keep getting closer and closer to this function. This is the basic point of what we're trying to do. We'd much rather work with things that look like polynomials than this nasty e to the x thing. So that's why we're going to study sequences of functions and series of functions. And the series of functions will normally be very nice, easy functions like x, x squared, x cubed, something like that. So we'll stop for here. Enjoy the chapter.